This is Jack Jackson. I'm going to be talking today a little bit about this hyperbolic geometry sketch that was put together by Nathan Wesly Clark. And Wesly was a student of mine a few years ago who put together this sketch as part of his senior project. He put together actually a variety of sketches. There's a student version of this and a teacher's version of this. The version that I believe I posted for you guys is the teacher version, so it has the most in it. This talks a little bit about senior project. This is his table of contents. And this talks about the hyperbolic half-plane module. And if you notice, it does go through a formal development of really neutral geometry and hyperbolic geometry here. And you have hide show buttons. You can always get back to the table of contents. Use the previous and next button. You can hide this introduction, and you can go in. There's some explorations. So it talks here about some different things here. And he's talking about defining a unit coordinate system, which I talk about in one of my other videos. And then naming the hyperbolic half-plane edge. So he goes through a little bit about how he came up with some of the tools a bit, and he also talks about the theory behind this in terms of the hyperbolic half-plane stuff. There's usually a reset button which will kind of turn things back to where they start. Okay. Then we talk about hyperbolic lines. We talked about this in a previous video. There are two types. There's the vertical line here and the non-vertical line. These are circles here with the center on the axis, and this one here is where the 2 points are vertical from each other, is a vertical Euclidean ray. In neither case does it include any points on the edge. That's infinity. There's nothing down here. All the points are up here above this. There are some interesting questions, and it would be instructive and useful for you to actually go through and read these questions here and to explore some of these things. So, for example, so if we have, what can we say about the line XY? Well, there's always one line that includes them. Now notice this particular one, when it changes color, that's whenever it's on the same vertical line. And this tool here combines both tools. Okay, so that it produces both lines. So that's going to be useful for us. This one sort of points out that if you have two lines that intersect, then they have to intersect in one point. Okay, but we can also have, of course, parallel lines like this red one and this blue one here. Okay, so let's see. There's the introduction. Here's the explorations. Okay, notice it has some of our definitions, pretty much the same ones we're using in class. And it will have some different things, a lot of hide and show things. This shows you how to use the custom tools. Okay, and this is a pretty well done sketch. So notice he has lots of tools here. So most of the tools that we have available to us in Geometer Sketchpad for Euclidean geometry, we now have versions here. There are a couple of different things for line tools. There's a line tool here, and this one includes a vertical line. But if you notice there's some weird things where it disappears. That's actually due to an inherent problem in Geometer Sketchpad, not in the design of his tool. So we actually ran up to some limits of the abilities of Geometer Sketchpad to do things in this project. Okay, so that uses a sort of a more traditional line. This one just specifically a vertical line, which of course we define by only needs 1 point. there's an improved line here, and the improved line has the improvement basically is that this one doesn't break. There's never a place here where it disappears. It does include the vertical, and it never disappears. And it took quite a bit of work to get around the inherent problems in Geometer Sketchpad to make that work. And there's some talk about that in this next tab. So how do you use the tools? Okay, so basically you use tools here. When you use a built-in tool, you select objects and then you use the tool. So like if you want to make a line segment between 2 points, a Euclidean line segment, you select the 2 points and then you select the tool, the construct, and say construct a segment. You can also use the tool over here where you select the tool basically and then select the 2 points. So it kind of works both ways depending on, at least for some of the tools. The way the custom tools basically work is you select the objects first, then you go through here and you select the tool that you want, say a hyperbolic line segment. Actually, you don't select the points first. You select the tool, and then you select or create the 2 points. And so that's a hyperbolic. These are hyperbolic line segments. Okay, it does have that case where they sometimes disappear there. So he's not using his improved line on these particular segments. Now, there is another option. You can hold down the Alt key, select the tool. Let's see, so if we select the tool first, then we select the 2 points, like that. But we can also do it this way. We can select 2 points, let's say here and here, hold down the Alt key, and then select the tool. You'll see which things are based on just 2 points here. And now we can select one of those like that. So that works. Holding down the Alt key makes it work like one of the Euclidean things up here, say under the construct menu. Whereas if you don't hold down the Alt key, it's more like one of the tools over here on this particular palette. Okay. So let's reset the page. Let's reset. Let's hide all this. Okay. There are teacher versions of some of these pages. So when you go along and see something about hyperbolic lines, you can link to the teacher page. And the teacher version, what it will have is when you have the explorations, it will sometimes go into more detail, and sometimes we'll have things that are not on the student version of the page. All right. So anyway, we have hyperbolic line segments, and you kind of already saw how to use the tool there. If you look at the exploration, there are some things that it will ask you about line segments. Again, it's useful to go through and read these. I'm not going to read every bit of this to you now, but they are related to the topics that we're doing in our geometry course. This talks about the plane separation postulate and how you can visualize that in terms of hyperbolic geometry. I think before when I talked about it, I gave you a Euclidean visualization of it. But of course that one works for the other geometries as well. This is also, it works for at least hyperbolic geometry. So this gives you how you can go using a hyperbolic segment and a hyperbolic line. The 2 methods, remember, of using the Alt key or not, those are basically available for each of the tools. Hyperbolic rays are going to be actually Euclidean rays up here, Euclidean line segment with an open endpoint at the bottom, or arcs of circles going to the edge. So it goes to the edge here, here, and here, but goes up vertical forever there. And either way, the length of that, as we take B, this red line segment is getting longer and longer and longer, approaching infinity as we approach the edge here, or as we go out this way. Okay. The improved creation here on the hyperbolic lines talks a little bit about the problems that Wesly had in working through this, and how he did some possible workaround. Let's see. The teacher version may have some more to it. I'm not sure. Let's see. Hyperbolic circles. Now it turns out, actually I'm going to come back later and talk a little bit about hyperbolic circles, but I do want to, I think we'll stop here. We'll come back and talk about hyperbolic circles in the next video.